Hello, and thank you for joining me. My name is Adam Rose, and I am the Water and Sewer Product Manager for XP Solutions, principally working with XP Swim. I've given some talks before on various topics, and today's discussion will be on real-time data, a little bit about the concepts of why that's important, and then how to use that with XP Swim. There will be another talk in the not too distant future about interfacing XP Swim with what I would call enterprise real-time data, data from providers who provide data as a service. Today's talk's a little different though, but let's get a little background before we get into the meat. The concept I'd like to talk about is my model based on reality? So beginning with kind of the question, what do I mean by that? Well, XP Solutions has a phrase, model with confidence, when we describe our software. That's not only the software itself, but also the support and the training, and basically all the people and products and processes that stand behind our software. And that helps people model with confidence. An additional practical way to model with confidence is to be able to calibrate your model, or at the very least, compare your model against real data. So when I say calibration, I don't mean calibrate against a different model. I mean calibrate against physical data in the system somewhere. Of course, that can be difficult. There are a lot of very real and very practical constraints against calibration, time and money being the chief constraints. And so what are we left to do? Well, today's talk will cover in the beginning how to collect data for a lot less capital costs, but it really also delves into how to connect data of any type into XP Swim in more and more real-time ways. So let me start with a previous project that I worked on. This was a sanitary sewer master plan, like many that the viewers may have been involved with. And by that I mean there were flow meters and rain gauges that were installed for the purpose of calibration wet weather events. But like many projects, there weren't enough flow meters or rain gauges to cover everything. It's just not practical to do that. In this particular project, we had a certain lift station that had a level indicator that was not functioning, and the mag meters on the pumps themselves were also not to be trusted. So unfortunately, there was not money to install a meter there, but we could actually install a depth sensor, which we did. This is some of the implementation. You can see a very rough circuit diagram and some bits and pieces of electronics that made up what I'm calling a brain, although that's being generous. It's just a few parts here and there. And a distance meter. And that was used to collect data, store it locally, and send it back to a server in real time to show what was happening in the lift station. Of course, taking that information along with as-built drawings could give us a good idea of how the lift station was actually operating. It was a neat project and it was useful. At the time, we did not take that data and put it directly into a hydraulic model. We didn't have software to do that. But today I will show you using XP Swim how you can in fact do that very thing. So today's discussion will be how to take real-time data generated in the field by something as bare bones as this and have it directly feed into XP Swim. So we're not going to use this system. This system is well worn and tried and tested and not something you'd want to be near in an office. So we're going to build a very scaled down version of even this system. We just spend a minute showing you what the system hardware looks like before we show you how it operates. So here's the bill of materials for this system. It's pretty basic. We're going to start with a microcontroller. This is going to be the brains of the operation. We'll use a Bluetooth connection to interface the microcontroller to a phone. Then we'll use the phone on either 3G or Wi-Fi to put data on a remote server. The data will be collected using this little ultrasonic depth finder. And we'll connect it together with some DuPont cables because we are not going to build something sturdy enough to need a circuit or a breadboard. And I suppose if you wanted to see all the rest of the materials, you could have something like an indicator LED, and in this case a 9-volt battery, and then a little enclosure. So all in all, you could get all of these parts today in about 2 weeks' time if you order them online, and for less than $50 for everything you're about to see. So now we'll move over to the demonstration part now that we've talked about the brief concept of real-time data and how it's important and some of the parts we use to collect data. So we're going to break this up into 3 different pieces. The first piece will show you the hardware itself, just to show you how it works. The second piece will show you the software side, show you the data it collects at the same time. Once that's done, we'll switch over to XP Swim and show you how you can pull that data in as you're actually collecting it. And so what you see here is the unit torn apart. You can see the distance meter and the Bluetooth gauge and the microcontroller. Obviously very bare bones, just thrown together from spare parts I had just for the purpose of this demonstration. And this is the same unit buttoned up. You can see an LED indicator that will show us if the unit is on and if it's connected to Bluetooth. And you can also, on the right side, the silver circle is a on-off switch, and then of course there's the actual distance meter. So we'll switch over to video and we'll go ahead and turn it on, and you see the flashing light means it's on, but it's not connected to the phone. So there's the distance meter and there's the flashing light. Now we've connected it to the phone, so it's not flashing, it's solid, which means we're actually transmitting data. So I'll take it and start moving it around up and down to show distance and change in distance. So we can do up and down. We can also move it over and do up and down, off, down to the floor. Do the same thing up and down yet again, turn it over to the wall, and turn it the other direction just to show variation. So the second part of the demonstration is covering the software aspects. In other words, you just saw literally a black box. Let's see what happens when we apply data from the box to the phone and put that on a remote server. So here you can see, in a way, 3 columns of information. The first is a map, the second is an actual table, and the third is a graph. At this point, there's actually nothing to see because we haven't placed any data here yet. But what we'll do is now connect the phone to the device and run the exact same scenario you just saw on the table, off the table, to the 2 different walls, while this page refreshes that data so we can see what actually happens. So let's go ahead and get started by connecting the Bluetooth. We should start seeing data soon. And there we go. Seeing data as we move up and down, up and down. And we'll just keep doing that up and down, and then off the table to show another big change. Let it register off the table, go a little bit higher, and then back on to just above the table. And then we'll let that sit for a second, again collecting a lot of data, and then we'll point it to the wall, let it see that for a second, and point it back to the other wall. And I'm going to just stop here just a second just so we can see what that data looks like. I'll go ahead and hit stop. Okay, so let's review what exactly we've done. If we look over on the left column, we'll see a dot representing where this data was taken. If I click here, you can see current time and then elevation reading. So I've taken the depth and a known offset and converted that into an elevation, which is pretty standard. Same thing was done in the project you saw before. So that's the most recent elevation. This table has all the different elevations. So again, these are depths converted into elevation based on a known datum, if you will. And that same data is shown in a graphical example. So these are time points basically in seconds on the x-axis, and that same depth on the y-axis. So what we're going to show now, all that to say, we're going to show how XP Swim can consume this type of data in real time. So just as I'm spitting out data every second and feeding it into a server, XP Swim can actually read in that data every second, and as often as you care to refresh your screen, you'll see that data. So I'm going to jump out of this server and show you XP Swim, and we'll see the exact same data in the same graph. So now we're back over in XP Swim with a very simplified model. I should of course state that while I'm treating everything here like closed conduit, there's no reason this couldn't be a gauge and a river station. I just happen to be partial to closed conduit sanitary systems. So the data that we took on and off the table and to the wall is meant to be representative of this manhole 2 here. So I want to use that data to calibrate, quote unquote, my manhole 2. So the first thing I'll do is double click and get into the editing data of manhole 2. And if I go to gauge data and gauge level, which is what I would expect for a manhole, you can see a text file that's referenced, as well as a user-defined file format. When I click on that user-defined file format of test and click edit, you'll see elevation, date, and time. And if I bring up the actual data, you'll see the same depth, date, and time. So I've just set up an interpreter to handle the data as it comes in. So the only step remaining is to actually pull that data in real time. And there are two ways to do that. The easiest way is quasi real time. And what I've done is set up a batch file, and that file just grabs the database from the server and puts it where it needs to go. And I really like this feature of XP Swim where I can go to tools and I can launch that kind of application. So I can launch a bat file or any command file that I want, executable or otherwise. And so I've made, if you look down here, real-time data. And if I run that, it just takes a second, and that's it. So instantly it takes the most recent data and places it where it needs to be. So if I go back to Manhole 2 and click on Review Results, now of course remember I took data for only about 40 seconds, and a typical model runs for days or weeks, so it's going to be compressed. So it's not much to see yet, but let's zoom in and see what this line looks like. And we'll zoom in a little more. And now, if you remember, that's very close to what we had before. So I'll jump back over to our other data and show you what that looks like. But you'll see that it looks almost exactly the same because it is the same. And so there's our data over here. You can see the same file. And so same format. So in this case, every time I want to see that same data, I would need to hit close, I would need to go over to run, and I would need to go ahead and launch this real-time data, which again is about 10 lines of code that just takes the data from the server and brings it local. So that's basically real-time, and honestly, for the sake of a model, that's probably good enough. In other words, how often do you need to rerun that? And if you did, you just have to click one button, so it's really not too bad. However, if you run an instance of the server on your machine, on your actual desktop or laptop, you can actually get truly real-time data. By that I mean every single time you hit refresh, it will be the most recent data. So if I go back here to review results, every single time I just hit hydraulics, it will be new results every single time, because every single time I hit hydraulics, it requeries or repulls that data, that text file. And if I'm running a local version, again, it doesn't mean I have to be sending the data from the phone to my laptop. It just means that I have to have a local version of what's running on the server on my laptop. And that's something that can quite literally be run on a USB. So you can plug a USB into your computer or install it on your computer and have straight real-time data. Every single time you refresh this, you will see exactly what you want to see. It'll be the exact same data from the field. But let's take a deep breath and summarize what we've done. So there's three main components. The first is the hardware, and so that was using a commercial board called the Arduino. The exact one you saw was called the Nano, and the other little components. That was the hardware there. And of course there's software required to make that hardware do something. And then there's a server that collected the data. So that was a lamp stack. So that was PHP, and then you saw some HTML and JavaScript there. And then there's desktop software, so there's a batch file that actually ran and pulled data from the server to the desktop. So at this point you may be incredibly overwhelmed, and what I just said may make no sense to you. And you may think that you might have to have some advanced computer science degree to do something like this, or perhaps you're in the other group and you're the kind of tinkerer who likes this type of thing. But I'm going to speak to the first, the group who what they just saw seemed interesting, but the knee-jerk reaction was it was way too complicated, way too complex to ever be involved in any of their projects. And so I just want to take what I just showed you, the hardware, the software, and the desktop software, and let your mind be somewhat at ease. Because Arduino code, the code that actually read the distance, is about 30 lines of code. The server code, you saw many extra lines of code that made it look nice, but as far as the required code to actually take the data and put it on the database, that was 15 lines of code, and the desktop software is about 5 lines of code. So if we add that up, that's 50 lines of code total in 3 different places. And if you remember, it was $50 to build this. So $50 in hardware, 50 lines of code, and you're getting real-time data. You're connected to the Internet of Things. Not bad to connect XP Swim for $50 and 50 lines of code. Of course, if you're in harsher terrain or you have more complex options, there may be some additional costs or additional lines of code. But for the vast majority of us, $50 in 50 lines of code isn't too bad. But perhaps you're someone who may say even 50 lines of code may be difficult for me to handle. That's where you may be happy to know that I'm going to release all the code behind this, the 50 lines that are required, plus the other maybe 100 or so that make everything easy, and all the different notes, and everything else you could possibly need, bills of materials, everything. If you want to reproduce this exact experiment, I'm going to release all of it. So just get in touch with me if you don't see a direct link as part of this presentation, and I will be happy to share it with you. I appreciate your time in this 15 minutes or so. Hopefully it's opened your eyes into ways you can interface XP Swim with almost anything. Right now we're talking about real-time data from home-built sensors. We'll have other discussions about real-time data with enterprise systems, and soon we'll have discussions with connecting XP Swim into enterprise asset management and lifecycle cost analysis software. Thank you again. You'll see my information here. Please don't hesitate to contact me.